everyone, and welcome back for another deep dive. You ready to get those brains working? Today, we're going to be looking at numbers and counting, which might sound simple,
Yeah,
but trust me, things are going to get pretty wild.
absolutely. It's incredible how much we rely on numbers every day without really thinking about what's going on behind the scenes.
Right, like I was watching this Vsauce video, and it just blew my mind.
Oh yeah, Vsauce, they always have some really interesting stuff.
Like, did you know there are people out there who've counted to 1,000,000? Like, actually counted to 1,000,000.
It's insane, right? Jeremy Harper, this guy, he spent like over 3 months just counting.
Can you imagine the dedication, just like counting every single second?
For 11 days straight.
That's 1,000,000 seconds.
Yeah, but to get to 1 billion,
Whoa.
that's over 31 years.
It's hard to even fathom numbers that big.
Yeah, it really puts things in perspective, doesn't it? Like
Yeah.
how we think about numbers and quantities.
Well, and speaking of how we think about numbers, the video also talks about this thing called logarithmic counting.
Yes. That's where things start to get really interesting.
I gotta be honest, though, when I first heard about it, I was like, Loga, what?
It sounds intimidating, but it's actually pretty simple. Instead of adding one each time like we do in regular counting, logarithmic counting is all about multiplying.
Okay, so instead of 1, 2, 3, 4, it's like...
It's like 13927. You're basically zooming out on a map, if you think about it.
zooming out.
Yeah, like imagine looking at your city on a map. The distances between buildings seem huge,
Right?
but then you zoom out to see the whole world, and those distances become tiny.
Okay, so it's all about relative change, not just adding one every time.
Exactly. And what's amazing is that our brains actually use logarithmic scales naturally for a lot of things.
Right.
Well, think about how we perceive sound.
Oh, okay, yeah. Like a whisper seems quiet and then someone shouts and it's a huge difference.
Right.
But if they keep shouting louder, it doesn't have the same impact.
Exactly. Our brains are wired to pay more attention to changes on the smaller end of the scale.
Huh. And is it true that, like, maybe we even perceive time this way?
That's one theory, yeah. Like, a year feels like forever when you're a kid,
Oh, yeah?
but it flies by when you're older. Maybe because that year is a bigger proportion of your life when you're younger.
That's trippy. So, like, this logarithmic thinking, does it affect our everyday lives, too?
Oh, absolutely. You ever heard of the psychophysics of price paradox?
I don't think so. What is that?
Okay, think about it this way. Would you work harder to save $5 on a $10 purchase or $5 on a $2,000 purchase?
I mean, honestly, probably the $10 one.
Right. Even though it's the same amount of money saved.
Yeah, but why, though? It's literally the same amount.
It's because our brains get fixated on the proportion saved. 50% off feels way more significant than saving like a tiny fraction of a percent.
So even if it doesn't make logical sense, our brains are still prioritizing proportions.
Exactly. It's like our inner caveman is still calling the shots sometimes.
That's so weird. Okay, so we've been talking about like counting these huge numbers, but what about when we don't even have to count? Like when we just see a small number of things and instantly know how many there are.
You're talking about subitizing?
Subitizing. Is that what it's called?
Yeah. Most people can do it with up to 4 objects. It's like our brain has a built-in number sense for small quantities.
I never knew there was a word for that.
Here's another fun fact. A lot of historical tally systems worldwide, they actually change their notation after 4.
Really? So like for as long as humans have been counting, we've recognized this limit of 4. That's fascinating.
It really is. But what about when we have to deal with larger numbers? Obviously, we can't just see the quantity then.
Right. So what happens then?
Well, that's where the approximate number system comes in. Think of it like your brain's estimation tool.
Estimation tool.
Yeah. It's not perfect, but it lets you compare larger quantities with about 15% accuracy.
So, like, I could tell the difference between 100 dots and 115 dots, even if I couldn't count them exactly.
Exactly. Yeah. The closer the numbers are, the harder it gets, though.
Makes sense.
The video actually mentions this online test called the Panamath test.
Oh, cool.
Yeah. You can check the accuracy of your own approximate number system. I've been meaning to try it myself.
Yeah, me too. It sounds fun. So we have this intuitive sense of number even for larger quantities, but then we all learn to count the traditional way. Does that, like, override our approximate system?
It's funny you should ask that because that's actually where things get even more interesting. Before kids learn to count linearly, they can actually make pretty accurate comparisons between groups of objects.
So they can tell, like, 6 is more than 4, even if the 4 objects take up more space.
Exactly. They have some innate number sense from a young age.
That's so cool.
Uh-huh.
So what happens when they start learning to count the normal way?
Well, around 3.5 years old, they can actually get tripped up by the physical size of things.
Really?
Yeah, they might see a longer line of objects and think it has more, even if it actually has fewer items.
So they're like prioritizing what they see over what they're learning about numbers.
It seems that way. Like they have to go through this phase of almost unlearning their reliance on visual cues and developing a more abstract understanding of quantity.
It's like their brains are going through this whole rewiring process.
Exactly. But the good news is, around age 4, as they master linear counting, they regain that ability to make accurate comparisons.
So it all comes together eventually.
It does. It's really amazing how adaptable our brains are.
So this whole deep dive is making me realize how much is going on in our brains that we don't even think about.
It is fascinating, isn't it?
Okay, so the video ends with this really thought-provoking idea about the smallest and largest things imaginable, the Planck length, and the observable universe.
Oh, yeah. Now we're getting into the really big questions.
I have to admit I was a little lost on that one.
Well, it all starts with a simple question.
Right.
What number is halfway between 1 and 9?
5.
That's the linear way of thinking. But if we think logarithmically, like we've been talking about...
No, then it's 3.
Exactly. Because 3 is 3 times larger than 1, and 9 is 3 times larger than 3.
It's the proportional midpoint.
Now imagine replacing that 1 with the Planck length, the smallest measurable length in physics, and the 9 with the size of the observable universe.
Well, hold on. We're talking about scales so vast, it's hard to even comprehend.
I know, right? But here's the mind-blowing part. When you look at the proportional midpoint between those two extremes, guess what you find?
I have no idea.
A human brain cell.
What? Seriously?
Yeah, the number of Planck lengths you could fit across a brain cell is equivalent to the number of brain cells it would take to span the entire observable universe.
That's incredible. It's like we're perfectly positioned in the middle of this cosmic scale.
It really makes you wonder about our place in the universe, doesn't it?
It does. I'm starting to feel a little cosmic myself after all this.
That's the beauty of these deep dives. They force us to challenge our assumptions and see the world in new ways.
And we've only just scratched the surface, right?
Exactly. There's so much more to explore.
Well, I'm definitely ready for more, but for now, I think we need a moment to process all this incredible information.
Yeah, let's take a break and we'll be back soon to continue our exploration of counting and perception.
Stay tuned, everyone. Welcome back, everyone. That last part about the brain cell and the Planck length
Yeah.
and the universe, it really has me thinking. It's amazing.
Yeah, it's definitely one of those things that makes you step back and go, whoa, you know?
For sure. But before we get too lost in the cosmos, I'm eager to keep going with some of these other fascinating ideas from the video.
Sounds good.
We were just talking about how kids develop their understanding of numbers.
Right, right.
And it's like way more complicated than you might think.
It really is like a whole journey for their little brains.
So before they can even count,
Yeah.
we were saying they can actually make accurate comparisons.
They can. Like,
Yeah.
they could look at two groups of objects and tell which one has more, even though they don't know the actual numbers yet.
But then they hit this weird snag.
Around 3.5 years old.
Yeah.
Uh,
Yeah, where they get confused by physical size.
Right, like they might see a longer line of toys and think it has more toys, even if it actually has fewer.
So it's like their brains are battling between what they see and what they're learning about numbers.
Exactly. And this whole struggle actually highlights how important abstract thinking is when it comes to numbers.
Abstract thinking.
Yeah, it's not just about seeing what's in front of you, but understanding the concept of quantity itself, like 4ness.
So they have to move beyond just relying on visual cues.
Exactly.
And develop a more sophisticated understanding.
It's like upgrading their mental software.
I like that, mental software. And the good news is they figure it out eventually.
They do. Around age 4, as they master linear counting, they regain that ability to make accurate comparison.
It all comes together.
It's like they're integrating their innate number sense with this new learned system of counting. It's amazing how adaptable our brains are.
It really is. This whole deep dive is making me realize how much we take our brains for granted.
Me too. We're constantly learning new things, and our brains just keep adapting.
Speaking of learning new things, I wanted to circle back to something you mentioned earlier about...
What's that?
About how our brains might actually perceive time logarithmically.
Ah, yes. That's a really fascinating one.
Yeah, it really caught my attention. Can we talk about that a bit more?
Sure. So remember how we were talking about proportions and relative change?
Uh-huh.
Well, think about it this way. When you were a kid, did summer vacation feel like it lasted forever?
Oh, yeah. It felt like those 3 months would never end.
And now...
Now it feels like summer comes and goes in a flash.
That's exactly what people describe. And this logarithmic perception of time theory basically suggests that it's because
Because.
each year we live represents a smaller and smaller fraction of our overall lifespan.
So as we get older, each year feels less significant because it's a smaller proportion of our total experience.
That's the idea. It's similar to that lion example we talked about before.
The one where one lion added to one lion is a big deal, but one lion added to 96 is like whatever.
Exactly. It's like our brains are wired to pay more attention to relative change than to absolute time.
So it's not that time is actually moving faster. No, it's just that our perception of it is changing.
Exactly.
Whoa, that's really mind-blowing. I'm going to have to pay more attention to how I experience time from now on.
It's a good reminder to savor each moment.
It is. Before we move on, though, I wanted to go back to something else we touched on earlier about the counting champions.
Oh, yeah, the people who take counting to a whole other level.
Yeah, we talked about Jeremy Harper, who counted to 1,000,000.
Mm-hmm.
But the video also mentioned Mike Smith, who holds the record for counting to the highest number in one breath.
Oh, yeah. He managed to get all the way to 125.
125! That's insane!
I know, right? Talk about lung capacity.
Seriously, I get lightheaded just thinking about it. I could never hold my breath for that long, let alone count that high.
It's incredible what the human body can do when we push it to its limits.
Right, and it makes you wonder, could someone count even higher in one breath?
It's possible. Maybe there's a future counting champion out there somewhere just waiting to break that record.
Maybe one of our listeners.
Yeah.
But seriously, folks, if you're going to try to beat Mike Smith's record,
Yeah.
please be careful.
And maybe start with a few breathing exercises first.
Good advice. It's not just about speed, but accuracy and endurance, too.
Exactly.
Wow, this whole conversation has been a wild ride. We've talked about all these different ways of counting, the mysteries of our perception, and even the vastness of the universe.
It's really amazing to think about the incredible power of the human brain, isn't it?
It is, and we've only just scratched the surface.
There's always more to explore.
Well, before we get too carried away, I think we need a moment to gather our thoughts.
Yeah, let's take a break, and we'll be back soon to wrap up this exploration of counting and perception.
Sounds good to me. And we're back. For the final part of our deep dive into the world of numbers, it's amazing how much we've learned about counting and how our brains perceive quantity.
Yeah, it's been a real eye-opener, hasn't it? All these different ways of thinking about numbers.
It's like we've been given this whole new perspective.
Exactly.
Mhm.
And it really makes you appreciate the complexity of something as simple as counting.
I know, right? Before we wrap things up, though, I wanted to go back to something you said earlier
Oh, what's that?
about how understanding these different ways of counting and perceiving the world,
Yeah,
it can fundamentally change how we see things.
it really can. Once you start to see the patterns and the principles behind it all, it's like you're seeing the world with fresh eyes.
Totally. It's like we've been given a new lens to look through.
A lens that reveals the hidden structures and connections all around us.
Exactly. Like, for example, the price paradox. Now that I understand our tendency to focus on proportions, it makes me question my own spending habits, you know?
Me too.
Mm.
It definitely makes you more aware of all the subconscious stuff that goes on when we're making decisions.
And it's not just about spending, right?
No, not at all. Think about how logarithmic scales can help us grasp the vastness of the universe.
Oh, yeah, that was mind-blowing. The
Yeah.
example with the brain cell being the midpoint between the Planck length and the observable universe.
It really puts things in perspective, doesn't it?
Totally. It's like we're right in the middle of this incredible cosmic scale.
Connected to everything around us, from the tiniest particles to the largest structures.
So after this deep dive, what would you say is the biggest takeaway for our listeners?
I think the key is to become more mindful of how we think about numbers and quantities. Like, are we falling prey to the price paradox without even realizing it? Are we letting time slip away because we're not paying attention to those smaller moments?
It's like we've been given all these new mental tools, and now it's up to us to use them wisely.
By understanding how our brains work, we can make better decisions and appreciate the world around us even more.
So the next time you find yourself counting something,
Yeah.
take a moment to appreciate the incredible complexity behind that seemingly simple act.
There's so much more going on than we realize. Our brains are constantly making comparisons and judgments, often without us even knowing it.
And don't forget about those logarithmic scales. They might not be as intuitive as the linear way we usually think.
But they can reveal a whole new level of beauty and wonder.
Absolutely. Well, on that note, I think it's time to wrap up this incredible journey into the world of numbers and perception.
It's been a fascinating conversation. Thanks for having me.
It's been a pleasure having you. And to all our listeners out there, keep those brains buzzing, and we'll see you next time.